Today we have Creighton Meyers. He's working as a hydrologist and geospatial analyst at the Naval Oceanographic Institute. Could you tell us more about what areas of geoscience you use in your current job?
Sure. I guess probably the most commonly used areas of geoscience that I use on a day-to-day basis involve mineralogy and sedimentology, as well as hydrogeology, hydrology, and a lot of geospatial information systems or geographic information systems.
Awesome. And do you have a specialization within that?
Um, if I had to put a specialization on it, it's probably riverine modeling. So using variety of different models, most commonly HEC-RAS, HEC-HMS, and the soil water assessment tool to predict a variety of riverine variables.
Okay, awesome. And then we'll have some more questions about your background and a day in your work life and what that looks like. And then we'll also have a Q&A session so more students can ask questions that they're curious about. So, when did you first get interested in the geosciences?
So I first got interested in the geosciences my freshman year at Baylor University, where I did my undergrad. Was my second semester. I kind of did what a lot of 18-year-olds did and came in as a pre-med major, and I don't know, that didn't really follow my interests. So I decided to take an intro geology course my second semester. I found it really fascinating, and I got some volunteer lab experience, and my interest just kind of continued to build from there.
What university degrees do you currently have?
So I have a bachelor's of science from Baylor University in geology, master's in geology from UT San Antonio, along with the GIS certificate program that UTSA offers, and master's degree in ecology and conservation biology from Texas A&M, and I'm still currently enrolled in their PhD program in ecosystem science management.
And was your journey through university continuous, or did you take some breaks at certain points? And if so, what prompted you to continue going?
So starting from my undergrad through really all my degrees, it's been a continuous path. Probably the only exception to that is starting my career, which I started about a year ago at the Naval Oceanographic Office while in tandem working on my PhD. And the big reason for that was COVID-19. So kind of decided to enter the workforce and work on the PhD part-time, since a lot of funding got disrupted with the pandemic.
And how did you choose your career pathway?
So while I was working with Dr. Haschenberger, actually at UT San Antonio, I applied for a scholarship called the Smart Scholar Program, which is through the Department of Defense. It will basically fund a undergraduate or graduate degree program, and upon completion guarantee a job with a facility that does relevant research or applies your area of specialty to assisting the U.S. Department of Defense, and they'll hire you on as a civilian scientist.
So, what steps beyond that led you to your career now?
Um, I mean, everything before that was academic. When I finished my second master's at Texas A&M, I was brought on with the Naval Oceanographic Office. A big reason, a big part of that was that quite a few employees at the Naval Oceanographic Office took an early retirement um, during COVID, and there was a need to bring people in. So,
And what do you view as the most important component in your background that's facilitated your career trajectory? Um, Maybe a certain credential or training or a license.
so they don't require a professional geologist license where I work. However, something that I'm currently working on is a license through the certificate program through the NGA that basically it's a sort of certification for um, becoming a geo analyst. It's basically kind of the practicing or professional certification within the DoD intelligence community. Um, and apart from that, probably the most useful training is my GIS background and um, developing river model knowledge through different training programs that I've been to for HICRAS and SWAT.
So now we'll talk a little bit more about a day in your work life and what that looks like. So, what kind of activities fill up your workday?
So, kind of something with every federal employee, we have lots of training, especially in our first year. There's a variety of different training, whether it's HR required or safety related for working in lab facilities, stuff like that. So generally, they'll put us on a training schedule, and we'll have a new training like every couple weeks that we have to take care of during that pay period. And in addition to that, we have these things called JQRs, which are job qualification requirements. And a lot of those are kind of hands-on training, teaching you about the types of products that we're responsible for delivering to our customers, as well as um, making sure that we're proficient in different technical skills or technical background. So, and then depending on the background that you come into the Department of Defense with, some of those can be kind of signed off on immediately, like when you start or upon demonstration of mastery of material in lieu of taking a specific training. It kind of just depends on what background you're from, and keeping in mind that the Department of Defense doesn't just hire scientists, right? So there are sometimes analysts that come in that maybe don't have the hydrology background for the riverine branch. Maybe they worked in oceanography for a lot of their careers, so they'll have to, I guess, meet those job qualification requirements and get that signed off on. So a lot that'll take up quite a bit of time. And in addition to that, we'll spend a lot of time interacting with customers. So we'll work with the National Geospatial Intelligence Agency, as well as Army Corps of Engineers and kind of other deployed assets that the DoD has kind of spread around the world. And depending on a requirement that they might have to assess certain aspects within rivers, we'll try to coordinate with our customers 3 times a week and get an idea for what products that they might be needing and how we can best address the questions that they might have. And then I guess in addition to that, we have quite a few meetings, whether they're within our branch or whether we're reaching out and working with another department. We have several departments in the Naval Oceanographic Office, and sometimes if one specializes in tides, we might need to know something about tides to look at characteristics in the estuary of a river per se, things like that. So coordination with other departments and then command. And with command, sometimes before disseminating a product, going through quality control, we'll have a briefing or go over it with officers in the command at our office, or the chief scientist or other scientists that might be involved with the project.
And how have those work activities evolved over time since you've started? Maybe with a promotion or a career advancement?
So I just started almost exactly a year ago in my current position. So they brought me in on what's called a career ladder. Uh, Generally, if you come in to the Department of Defense with a bachelor's, you can be assigned a GS7 and you'll be on what's called a 7-9-11 ladder. If you meet all of your training, job qualification requirements, and proficiencies, you'll get automatic promotions once a year progressing through that ladder. So 7 to a GS9, GS9 to an 11. So I'm about to go to an 11. Mostly what's expected when you're first starting, of course, is familiarization with not only the products and the trainings, but also getting used to the idea of working with security, um, security clearance requirements, and handling of documents and that kind of thing. And then kind of as an 11, you branch out more to working with products and giving direct briefings and interactions with customers, and ideally less training. And then eventually a lot of people, after they reach an 11, after a few years, the next step, I guess, is going to a GS12 position. And the biggest difference on that, as far as I'm aware, is you end up leading different projects and having different analysts work kind of in collaboration with you to get a task done.
So, what are some geoscience related tools that you use in your work?
So maybe not geoscience specific, but we use a lot of GIS or GIS based tools through Python scripting, in addition to Esri's GIS. Sometimes, depending on the requirements, we'll use QGIS. There's a lot of using remote sensing software like Envy and Socket GXP to kind of build and assess products using a variety of different imagery, including satellite imagery. And reading, I would definitely say knowing how to read and use geologic and topographic maps comes into play for a lot of our products. And then Dr. Haschenberger might get a laugh out of this because it reminds me a lot of when I was in the grad program there. We'll do sieve analysis. So looking at different sediment samples that we might procure and kind of figuring out their bulk densities and other properties, kind of getting an idea for how much water saturation given sediment might have, whether it's in a riverine or an ocean environment, and maybe how much weight that sediment can bear at its surface, and other properties such as looking at characteristics that might lead to a good or a bad location to place a temporary bridge to cross a river in a war zone, that kind of thing.
And what kind of analyses do you perform in your work?
So I guess jumping off that last question, We derive a lot of vectors. So basically in GIS, if you're familiar with vector data, typically, I guess a go-to example, a lot of people will be familiar with our roads, that kind of thing. If you're looking at a personal GPS, we will derive a lot of vector features, pointing out possible hazards of navigation, center lines at the surface, as well as trying to derive bathymetry for coastal areas as well as rivers. And those vectors can be applied not only to traditional map products, but maybe in things like heads-up displays or other computers that might be used in the field. And in addition to that, we do a variety we run a variety of models in the riverine environment to predict characteristics such as discharge, um, you know, predicting characteristics like currents for boats or vessels that might be navigating upstream, and doing flood inundation analysis. So in addition to supporting our own Department of Defense assets abroad, we also have a humanitarian component. So when there are disasters such as the tsunami in Indonesia, for example, we have a team that can be sent out and deployed to take bathymetry measurements, as well as conduct surveys to basically use, to sum it up, we basically use a lot of imagery products to kind of discern characteristics that the warfighter might be interested in, or for humanitarian relief overseas in both riverine and coastal environments.
And what new skills have you gained in your career since completing your degree?
So we were talking about the first year involving a lot of training, just to give kind of an idea of that. In addition to kind of the in-house training, I've been sent to 5 different 24-hour Esri courses on different aspects of GIS, with the idea of going for some of Esri's professional certifications. I've been sent to Denver, Colorado for a week to kind of have a familiarization training with HEC-RAS, and specifically looking at dam breach models and assessments. And I'm going to be sent theoretically in October of this year to the San Francisco area for a 1-week HEC HMS, which is another modeling software training. And then in addition to that, completing an Esri or an Envy workshop. So that's kind of, I guess, the skills that I've been working on sharpening since starting my employment.
Is there other STEM disciplines that are applied in your work, like physics, chemistry, computer science?
Definitely. I guess understanding the riverine environment, especially when it comes down to modeling it, you need to know a little bit. It kind of seems like you have to be a little bit of a jack of all trades. So, a lot of physics goes into calculating the movement of water or runoff off of surfaces. Chemistry and that the kind of composition of the sediments goes into determining land use inside watershed basins, and kind of figuring out and making calculations about groundwater, especially as it interacts with the fluvial environment. And then biology, especially in remote sensing, to kind of assess the different types of vegetation and how that will influence not only evapotranspiration, but kind of groundwater infiltration. Math goes into all of these computer models, although luckily the computer can take care of a lot of the more complicated math. And computer science, actually, one thing that I wish that I had quite a bit more background in was programming. Kind of the two dominant languages that have had a variety of applications in my immediate work are Python, which I had an introductory course to in my master's program there at UT San Antonio, and then R, which I kind of had a couple of short trainings on while I was at Texas A&M, but never a formal course. And it's definitely something that I wish that I had a deeper background in.
What courses or skills do you recommend to students waiting uh, or wanting to work in your area of geoscience?
So definitely jumping off the last question, the two programming skills, if there are course specific or courses that are specifically offered for R and Python, I'd highly recommend that. In addition to that, I'm very glad and use a lot my remote sensing and GIS knowledge. And I'd probably say hydrology, hydrogeology, as well as fluvial and coastal geomorphology, if those are offered.
Okay, and that concludes the questions that we had for you. So now we'll open it up for a Q&A for anybody to ask a question to Creighton. I have a question about the SMART program and what got you interested in the SMART program, how you or if you decided on the kind of, I guess, designation or field that you were going to go into with that, and then like what were the requirements for that? I guess just some more details on uh, the program.
Sure. So I was interested, I guess, for a little context. I kind of worked with a lot of suspended sediments and kind of focused on that in my undergrad, and came to UT San Antonio to broaden my horizon on, physical sediment transport within the bed. And I guess from there, wanting to concentrate or focus on rivers, the next logical step to me was to look at integrating the two using modeling. That kind of came to me as part of completing the GIS certificate program that UTSA offered in conjunction with the geology degree. And so while I was at UTSA, I saw a flyer that was talking about it, and I was in my interest in looking into PhD programs. I kind of came across the SMART program while looking at other opportunities such as EPA STARS and the NSF GRFP. And so I, if we're being honest, filled out applications for all three programs. I happened to get accepted under the SMART program, and they funded my research and tuition and fees to go to Texas A&M. The original idea of it was to complete PhD while at Texas A&M, and I'm still working on that now. But they give you a set amount of funding. You can apply up front for anywhere from 1 to 5 years, I think, is their funding max. And basically how it works is that every year of funding that you apply for and accept, you are guaranteeing 1 year of service as a civilian for the Department of Defense, and they will try to place you with a facility that best utilizes your skill set. I actually was originally placed with the Air Force and was going to work back down in San Antonio and Del Rio. But then I guess midway through my degree, the data set that I was using in conjunction with them was no longer available for my research. And the Naval Oceanographic Office had a data set that we were interested in pursuing. And I was reassigned to them, and that so far seems to be a really good fit.
So you located nearby Texas A&M?
Currently, no. So the Naval Oceanographic office is actually uh, hosted at the Stennis Space Center, which is in Mississippi. So I moved to Mississippi a year ago.
Okay. And then we have a question in the chat. Um, do hydrologists spend much time on boats? And then I'll kind of extend that question to how much time do you spend uh, using GIS software or remote sensing software versus other computer applications, or how much time you spend in the lab, and I guess anywhere else, maybe on a boat.
So I guess that all depends on not only who you work for, but even within my agency. So I am in a non-travel position and primarily work with river models and image analysis. So I would say, I mean, there's a lot of overlap, especially between like HEC-RAS and HEC-HMS. The interface actually reminds me a lot of the old ArcMap interface, but GIS or GIS like stuff probably takes 80 or 90% of my work time. And I'm in what's called a non-travel position. So the Naval Oceanographic Office um, has 7 survey ships, and they will actually conduct surveys worldwide, taking sediment samples from the ocean floor, taking bathymetric surveys of the ocean to update maps for navigation, and um, kind of other deployment stuff. And then they also have like the fleet survey team, which, as I was talking about earlier with the tsunamis in Indonesia, they were able to send out that team, which spends a lot of time on boats doing kind of hands-on analysis and surveys. So in my particular position, I don't unfortunately get to spend a lot of time on boats, but there are quite a few people who spend lots of time on boats. And uh, yeah, there's some cool travel opportunities working for where I work in different positions anyway, where if you want to travel and see the world, well, you can volunteer for a survey, or you can, if you get a job requirement that requires surveys 2 or 3 times a year, the Department of Defense will pay for your travel to and from the ship location. And a lot of people will take shore leave or extra time off and see other countries around the world.
And Corinne has a question.
Yes, I do. Thank you for coming and talking to us today, Creighton. So I'm going to loop back to your Python wishes that you had advanced in that prior to starting your career. Would you say that the program statistics course was enough to prepare you for your current job? And are there resources that you know of? If I'm, for instance, I'm in the programming statistics course for Python, and I'm kind of maxed out on the credits that I can take at UTSA currently to kind of further progress my knowledge in that. Are there resources that you maybe wish or you know about, or you wish that you had used to kind of on your own progress? And then the third part is, do you use this Python more in a GIS application, or are there other softwares that you're using this programming for?
So for me, I pretty much use it exclusively in GIS environments. and it's really useful for streamlining incredibly repetitive tasks. So that's kind of mostly the nature that I use it in. Esri has a lot of free, as long as you have an Esri account, there are a lot of free kind of online tutorials and trainings that, might also be worth like 1 or 3 hours of I forget what they call it, but anyway, they're free training courses. And then personally, I've found a couple of the Esri 24-hour short courses that I've been allowed to take through the DoD have been pretty helpful with Python, especially in direct application to GIS. But that's mostly what I used it for. And I don't think that Python scripting for statistics was a course when I was there at UTSA 5 years ago. It was more an introduction to Python.
Okay, thank you. Yes, I do a lot of the Esri trainings, but that's the only resource I knew of. So, okay, thank you.
Am I next?
You're next.
So I wanted to follow up a little bit about the GIS certificate and kind of related to Corinne's question in the sense of when you look back in that certificate, did it do a good job preparing you, kind of providing that foundational information and knowledge that then you've been building on since?
Yeah, I actually think it provided a really good, more broad-based jumping off point. And then I guess I kind of wish that there were a few more. I mean, I know it's limited to like five courses, and the Dr. Weisling's remote sensing as applied to hydrology course was especially useful for what I ended up doing. But I would highly recommend the program as like a good base knowledge for GIS if you don't have that background. That's been one of the more useful things from the academic side of things applied directly into, as part of the workforce.
And then I have a very different kind of question, because I think sometimes students are always thinking about the science side, the skills associated with the science side, but I'm curious what your perspective is about interfacing with these customers and what kind of soft skills have you found to be critical in doing that part of your job well?
Yeah. Boy, that gets hard sometimes. I guess the ability to articulate and kind of convey what you'd like to say as a scientist. A lot of our customers, whether they're National Geospatial Intelligence Agency, another intelligence agency, or some people who are deployed in our military forces, they don't have a scientific background at all. Actually, a good example of this was, I guess, trying to articulate what a watershed is and why a watershed boundary is important, and why, a river is not going to cross another watershed boundary, from like a customer who was kind of looking to maybe assess navigation in a part of the world where, it would have been convenient to use rivers, and just having to kind of convey the science that, when you have this watershed boundary, the water's draining in opposite directions and these two systems don't interface. So yeah, developing kind of the patience and the skill set to convey maybe more complex scientific terminology in a way that's understandable and relatable is a very important skill set.
Thanks for that.
A question about the data that you work with. How much of the data is open to the public versus how much of the data that you're working with is secure?
Personally, in my experience, it's about a 50-50 combo. And a lot of what we might have access to, you guys might all have access to on the open source side, maybe at like a lower resolution or something like that, right? So, I mean, in terms of building these river models, I end up approaching them for my work in a very similar way that I would in academia, and that is to find and use, the best resources that are available to me. If that ends up being secure data that we have that's proprietary, then I'll use that. And there's also plenty of times that we'll use not only other US government resources that are open to the public for the US, but if we're looking at the globe, there are a lot of European agencies and other agencies worldwide that disseminate data publicly. So really it comes more so down to what the application is and finding the best available data.
And is there any other questions for our Q&A? Is there anything or any final statement that you want to make to the students? Any recommendations for courses, skills, resources, advice?
I guess probably just always maintain having an open mind. I got a lot out of attending, not only talks from other professors visiting when I was at Baylor, but we also had a seminar course when I was at UT San Antonio, and then again at A&M. And even at the DoD, we'll have visitors that'll give talks about like new products or other kind of analyses that other divisions that we can liaison with offer. And taking those opportunities to learn and hear from other people is really good for cultivating kind of your own background knowledge, as well as it's good for innovation and continuing to figure out how we can apply new advancements or new topics into work that's already being done.
Okay, awesome. So now we'll conclude the GeoChat. Thank you, Creighton, for your time, for coming in. Thank you, everyone, for joining and asking questions.